Good afternoon, class. We're looking at Chapter 9, Systems of Equations and Inequalities. Here's 9.8 Determinant and Cramer's Rule. So we covered various parts, and now we are covering Determinant and Cramer's Rule. The objectives are to evaluate the determinant of a 2x2 matrix, use Cramer's Rule to solve a system of 2x2, evaluate determinant of a 3x3, and use Cramer's Rule to solve a system of 3x3. Matrix is defined as a rectangular array of numbers. Matrices are classified by their dimensions, the number of rows and columns. A matrix with m rows and n columns has dimensions m by n. Here's an example. We have 1 row, 2 rows, 1, 2, 3 columns. So this is a 2x3 matrix. A square matrix has the same number of rows as columns. The dimension of a square matrix is n by n. A matrix with only 0 elements is called a zero matrix. The elements of matrix minus A are the additive inverses of the elements of matrix A. Summary of matrix addition and subtraction. If A and B are both m by n matrices, then the sum of A and B, A plus B, is a matrix obtained by adding corresponding entries of A and B. The difference of A and B, meaning A minus B, is obtained by subtracting corresponding entries of A and B. So A plus 0, by the way, this 0 is not a zero number, it's a zero matrix, and it works just like numbers in essence. Remember, a number plus 0 is the number itself. So A plus 0 equals 0 plus A, again, 0 is a matrix, is equal to A plus minus A, or A minus A is 0, A plus B is B plus A. Commutative property of addition, A plus B plus C in any order is fine. That's called associative. So A plus B and then plus C is A plus the sum of B plus C. Now, let's look at product. The product of a scalar, a number, and a matrix A is a matrix K times A, each of whose element is K times the corresponding element of A. In other words, multiply this number K by every element. The product of AB and n by n matrix A and n by K matrix B is n by K matrix and is found as follows. So the number of columns of the first and the rows of the second must be the same. The number of rows come from the first one. The number of columns comes from the second one. Here's the process. I've gone over that. You can find it in the recorded session. You can use matrix editor and use graphing utility. The identity property says an n by n square matrix whose diagonal entries are ones while all other entries are zeros is called an identity matrix. So identity matrix, the main diagonal is 1, the rest of them is 0, and you can multiply that by A in any order to get an A. However, if A is not a square matrix, the identity from the left and the identity from the right are two different sizes. They have different dimensions. If A is an n by n square matrix, then we call it IN. A times IN or IN times A is the same thing. And the answer is A. Solving systems with Gaussian elimination. Matrices and technology. Matrix methods enable calculators and computers to efficiently handle and solve large systems of equations. Matrix row transformation. It's an efficient implementation of echelon methods. So what matters is that when we have a large number of variables, so it gives us a system of a large system, it makes it a lot easier using the addition method, but using the matrices. So given a system, here's the system. We make it into an augmented matrix. So we write A1, A2, A3 in the first column, B1, B2, B3, C1, C2, C3, and D1, D2, 3. So those are the rows, those are the columns, okay? And this is the augmented matrix. This is called an augmented matrix where each member of the array is called an element or entry. The rows of an augmented matrix can be treated just like the equation of a linear system. So look at this one. This is called the coefficient matrix. This last column is the constant matrix. This line segment, in essence, is the equal sign. That's why we are combining these two in this fashion. Each column on the left represents a different variable. On the left, we mean the coefficient matrix. So that gives rise to matrix transformations. Row transformations resulting in a matrix of an equivalent system for an augmented matrix are the same stuff that we did to equations. Any two equations, we can change them, right? So any two rows may be interchanged. The elements of any row may be multiplied by a non-zero real number. We can multiply both sides of an equation by any number as long as it's not zero. The same concept. Any row may be changed by adding to its elements a multiple of the corresponding elements of another row. Remember, if you have two equations, you can multiply one of them and add it to the other one. That's what we did with the elimination. And that's the same concept with the rows. Matrix method to solve systems of linear equations. REF, row echelon form or row echelon method. Apply row transformation to get ones along the diagonal and zeros below the augmented matrix, or REF, reduce row echelon method or form. Apply row transformation to get ones along the diagonal and zeros both below and above the augmented matrix. So that's the synopsis of the previous section. And now 9.8 solving systems with Cramer's rule. Determinants. So the very first thing is, what about determinants? A matrix is square provided that the number of rows equal the number of columns. For any square matrix, we can compute its determinant as follows. Suppose that A, B, C, D are four real numbers, the determinant of a 2 by 2 A, B, C, D, okay, denoted by, it looks like an absolute value. This is the determinant sign for a matrix. We just do the cross product. AD minus BC. That is the methodology to find the determinant of a 2 by 2 matrix. Two by two matrix, and that's the key. Evaluate the determinant of the following matrices. Basically, multiply these two, and subtract this from the other. So 2 times 9, 18, minus the product of these two. This is plus 20, they add up to 38. What about this one? Again, cross product. Multiply these two, minus multiply these two. Negative 3 times negative 5 is positive 15. 8 times 0 is 0. So we get to 15. Same thing here. Um, they put it in a determinant symbol. So determinant of A, let's put this in a determinant symbol. That's, they call it DETA, or determinant of this, and they put it in an absolute value sign in essence. The product of these two, negative 3 times 8 minus the product of these two. So we get negative 40. So it's very straightforward, class. And now using technology, here I calculated first matrix editor. Remember, we go to matrix editor by clicking second x to the power of negative 1 and use the arrow key to the right to edit. And you put the dimensions. For example, we're going to put the dimension 2 by 2. And we're going to do one of them. For example, if we put the A matrix 2 minus 4, 5, 9, we are putting this one in. Then we go to math, we find determinant, and we put the matrix A in there. It will give us the same answer that we found here. So obviously technology can do that. Cramer's rule. Gabriel Cramer, 1704 to 1750, was a Swiss mathematician and has a lot of text. So Cramer's rule for two equations containing two variables. The solution to the system of equation. Here's what we have: ax plus by equals s, cx plus dy equals t. We call this the first equation. This one is the second equation, is given by. So of course that if the bottom is not 0. What we have here is the D matrix, and it uses the augmented matrix and find its determinant. We call it D. So A, B, C, D, which is AD minus BC. So now note what we do here. We replace the first column of D by the solution matrix D sub x, S and T, we put it in the numerator. If you look at the denominator for X and Y is D. What is the numerator for X, which we call it D sub X? We keep the same thing, the first column, we change it to the solution matrix. And for this one, the second column, because Y is the second column, we change it to the solution matrix. That's the methodology, everybody. Let's use Cramer's rule to solve the following system. First, we are going to write the D. The D would be the coefficient matrix. Write the determinant for 2 minus 5, 4 minus 2. And it's the cross product, 2 times negative 2 minus 4 times negative 5. Negative 4 plus 20 gives us 60. Now for d sub x, we just replace the x column with the solution one. The x column, we change it to negative 213. Product of these two, minus 2 times minus 2, minus the product of these two. This is obviously positive 4. This is minus 52, resulting is in minus 40. We go back to the D. For D sub y, we keep this one and we change this one. Of course, to that, okay? 2 times 13 minus negative 2 times negative 5. 26 minus 10 is 16. Now, we are going to follow x is d sub x over d. D sub x is minus 48 over 16. We get negative 3. D sub y is dy over d, which means 16 over 16, which means 1. And therefore, the result is negative 3, comma 1. That is the solution. And you must check. Check all this. How do you check? Just put it back into both equations and check. That's how checking works, everybody. I can't emphasize this enough, okay? For example, 2 times negative 3 is negative 6. 4 times 1 is positive 4. They add up to negative 2. You have to check the second one also. So check your work for sure, okay? Let's do this one. The coefficient matrix is 5, 6, 7, 8. So we want the determinant of that as D, which is 5 times 8 minus 6 times 7. 40 minus 42 is negative 2. So for D sub x, replace the column x with negative 1, 1. Minus 1 times 8, minus 7 times 1. Negative 8 minus 7, they add up to negative 15. For D sub y, we go back to the D. and we keep the first column, the Y column is changed now. So please understand it's the Y column that we change. When we do that, we get 5 times 1 minus 6 times negative 1. This gives us positive 5. This gives us positive 6. They add up to 11. Now we are going to divide this 2 by D. So this gives us negative 15 over negative 2 or 15 halves. This gives us 11 over negative 2 or negative 11 halves. So the solution set would be 15 halves, negative 11 halves. You must check. So you put it into the first equation, you put it into the second equation, you make sure it works. I'm going to leave it for you to check it. You must check. I can't emphasize this enough, everybody. Technology. Determinant of A. The matrix A is 5, 7, 6, 8. B is minus 1, 1, 7, 8. And C is this one. The determinant of B over the determinant of A and change it to fraction is 15 halves. The determinant of C over the determinant of A and change it to fraction is negative 11 halves. So very fast you can come up with the answer. It doesn't take long, everybody. So a 2 by 2 matrix, Cramer's rule is pretty straightforward. Determinant of a 3 by 3 matrix. The value of a determinant of a 3 by 3 matrix may be defined in terms of 2 by 2 determinants as follows. So if you have a 3 by 3 and you're going to call this A11, A12, A13, A21, A22, A23, A31, A32, A33. Remember, first we go with the row, then with the column. So distinguish between these two. This means row 1, column 2. This means column 2, row 1. First of all, determinants can be expanded with respect to any row. Can be this row, this row, this row, and therefore the row that has the most number of zeros would be most convenient. So if you are following that, then you're going to multiply this, and then, for example, here, let me just write the answer and I'll show you how we arrive at this. So how do we get this one? How do we get this one, everybody? We drop this one, and this is what you get, the determinant of that. Why are you dropping the first column? Because you're using A11. Now, the signs will alternate. This is A11, then it's A12, then it's A13. So if this is positive, this is negative, this is positive. I will show you that we raise negative 1 to the power of I plus j, and I and j are 1 and 1. They add up to 2. I will show you that one also in a moment. But how do we get this one? Let me erase my work again. So A12, you cross this one now. So you have A21, A23, A31, and A33. This is A31. A31. Because you cross this out, okay? You cross this out. You cross this out. So what is left? This is what's left. A21, A23, A31, A33. That's what is left. Now, for this one, you cross this one, and this is what is left. A21, A22, A31, A32. And you know how to find the matrix of a 2 by 2. Okay, it's a very straightforward. 2 by 2 determinant left after removing row and column containing A11. So the row and column that contains A11 is left. This one, 2 by 2 determinant left after removing row and column containing A12. A12, the row and column get rid of it. And this one, after we remove A13, A13, the row and the column leaves you there. That's how you arrive at it. The 2 by 2 determinants are called minors of the 3 by 3 matrices. That's as far as terminology is concerned. Okay. So minor of A11, minor, minor. Okay. And of course, we call it cofactor, including the sign. This is negative, this is positive, just so you know. Here's an interesting methodology to do it. You can do this actually a tad faster. If you put two of them next to each other, so you put two of them next to each other, you start from the very first one and you go diagonally. So you add the product of those three. A11, A22, A33 plus A12, A23, A31 plus A13 times A21 times A32. So you add them up. Minus, now you go from the very first one and you go diagonally this way. So minus the product of those three, those three, those three. Take a look. So the blue ones, you multiply them and you add them up. The red ones or purple ones, you multiply them and then you subtract. You add them up and you subtract the total from that. This will give you the same answer, everybody. That might be a tad fast. So let Mij be the minor for element Aij, which is an n by n matrix. The cofactor Aij, written as capital of Aij, is the same thing, but times the sign. And how do we obtain the sign? Remember, if you start from the very first one, then you alternate. But the reason it becomes positive and then negative, the very first one is the element of A11. 1 plus 1 is 2, and negative 1 to the power of that is positive. So minus 1 to the power of the sum of row and column. Okay. So what is the determinant of this? A11 times A22, A33 minus A32, A23. I showed you in the previous page. When you do the cross product of those and the rest of them. You don't have to memorize them, you can work it out. Now, what's interesting, we can choose to expand across any row or column. So for example, if you decide to go with this one, you're going to say A12 times what's left, but you have to put, you have to start with the negative sign because -1 to the power of I plus j, I is 1, j is 2. I plus j is 3. So that's why this one starts with a negative sign. See, if you go with this one, expand down the column. So this column will be going away, this column, and then this row, and then you have this 4. We get just the first one. And again, -1 to the power of 1 plus 2. So for this one, you don't have this one. You don't have this one. So what do you have left? You see that? A21, A23, A31, A33. Now, let me erase my work. Now A22. A22 times what? You are going to cross this one and you're going to cross this one. So the elements are left are A11, A13, A31, A33. And this one, again, -1 to the power of I plus j, which is 2 plus 2, which makes it positive. And now the last one is this. Again, -1 to the power, because we're going to use this one. Okay. And what is left? This one, this one, this one, this one. So very straightforward. Bear in mind that this becomes negative, this becomes positive, this becomes negative. Don't forget the sign. That's why they will alternate as long as you know the first one. So this one will always be positive because 1 plus 1 is 2, -1 to the power of 2 is positive. If you want to use this row, everybody, expand across row 3. So first, get rid of, first of all, -1 to the power of 3 plus 1, which makes it positive. So let me just, this is the one, and how do we arrive? Again, this is 3 plus 1 because this is 3 plus 1. You get rid of this 2. Look at this. Is this determinant? You see that? Same thing for the second one. Okay. You want A32, so get rid of this. So you get A11, A13, A21, A23, and the last one follows in the same. Okay. In other words, you can expand it with respect to any row or even column. Note the sign alternates, meaning as long as you get one of them, this is negative, then this becomes positive, this becomes negative. This is positive because -1 to the power of 4, then becomes negative, positive. The signs alternate. Let's look at this example. And again, -1 to the power of I plus j, mh. Because doesn't matter which row or column you decide to expand, ultimately remember the fastest way is to use the easiest one. If a row or a column has a bunch of zeros, that would be the best. Okay. So let's say we're going to go with the first row. So if I'm going to go with the first row, then -1 to the power of I plus j is 1, -1 to the power of 1 plus 1, or just the very first entry gives you positive. And you're going to drop this one. So I'm going to put an arrow. And this is the determinant. So 1 times the determinant of that. Please understand, -1 to the power of 1 plus 1 is positive, everybody, okay? It will alternate, but I want to show you. Now we go with this one. So -1 to the power of 1 plus 2. So we are going to go with number 2. So if you go with number 2, the blue does exist. So this row is completely gone. This column is gone. So you have 3, 1, 2, 7. Minus 1 to the power of 1 plus 2 times 2, which alternates. And this is the determinant. What about this one? That means this is left. So minus 1 or just plus negative 1 to the power of 1 plus 3. So makes it plus 1 times, because it's being raised to the power of I plus j, which is 4, which is even. So it becomes plus times 1, and then this one, the determinant of this. That's very simple. So for each case, 5 times 7, 35, minus 6, 29, 3 times 7, 21, minus 2 is 19, 3 times 6, 18, minus 10 is 8. This is positive 1, 1 times 29. This is negative 1 with 2, negative 2, negative 2 times 19 is negative 38. Positive 1 times 8 is 8. They add up to negative. So it's really not too bad. It can be done by hand, of course. But if you have a bunch of them, you can always use technology. Evaluate the determinant of a 3 by 3. Any row or column will do. If we go with this, remember, as far as that negative 1 to the power of I plus j, just alternate. The first one is positive, okay? So 5 times, get rid of this, the determinant of that, minus 8, get rid of this, the determinant of this 4, plus 6 times, get rid of that, the determinant of this. We choose to expand across row 1. By the way, row 2 or column 2 would have been easier, everybody, just for the sake of argument, because it has a 0. In any event, so 5, drop this, and this is what you have. Minus negative 8, drop this. You have 3 minus 5, 4, 1, right? And then 6, drop this. This is what you have. So this one is 0 minus 8. This is 3 minus 4 times negative 5. This is 4 times negative 5 is negative, so it becomes positive. So 3 times negative 2, okay, or minus 6. This is 0 there, product. So again, 5 times 0 minus 8, minus 8 or plus 8, 3 times minus 4 times negative 5, which is negative 20, plus 6 times negative 6 times 0. You put it into, you simplify it, and you end up with 188. I'm assuming everybody can do this. Is basic math, everybody. So 5 times 8, 40, plus 8 times 23, 184. 6 times 6 is 36. We have a negative sign. Put them together, we get 180. The second method is to just write the same thing next to it. And by the way, if you want to go with the technology, you put this into some matrix. I put it in matrix B, 3 by 3. I looked up the determinant of B. It generated 188. Method 2, just write two of them next to each other. Go this route. Remember, I showed you this one. You are going to say AQZ plus BRX plus CPY minus the sum of those. Okay. So we are going to say 5 times 0 times 1, plus, which makes it 0, plus negative 8 times 4 times negative 5, plus 6 times 3 times negative 2. So that's the blue one. Minus negative 5 times 0 times 6, which is 0. You add up those three. Minus 2 times 4 times 5. Added to 1 times 3 times minus 8. So you add up those three and you subtract from the blue one minus the purple one. You get 124 minus negative 64. It gives you 188. So you can do it this way. You can do it this way. As long as you know either one is good enough.
Dad, I need help.
So that's the determinant of a 3 by 3, which gives rise to the Cramer's rule for three equations containing three variables in the following manner. D is the determinant of the coefficient matrix. That means ignore that and use that. Now, for D sub x, we are going to put this one here for the first row. So the x column, the first row, changes to the solution column for D sub x. For D sub y, the second one changes to this. And for D sub z, the last column changes. And now the same formula as before. X is dx over d, y is dy over d, z is dz over d. So it's pretty straightforward. Here's an example. We wanted to use the Cramer's rule to solve. First and foremost, we start with the D matrix. And normally you don't have to do this by hand, but just to show you. So 2, 3, 1, 3, 7, negative 1, 0, minus 4, 2. That's the D matrix. We are going to expand it with respect to something. For example, the first, if we go with the first row, okay. So 2 times, you get rid of these 2, 7 minus 4 minus 1, 2. Actually, we are expanding it with respect to this one, everybody. With respect to the first column. So they alternate, the sign alternates, so minus 3. So if you cross these two, you're left with 3, 0, minus 1, 2. Okay, everybody. And finally, plus 1. Get rid of these two times those that you can see. Again, expansion with respect to the first column, first row, any of them makes no difference, everybody. So this one is 7 times 2, 14, minus negative 1 times negative 4 is 4. This one is 3 times 2 minus 0. This one is 3 times minus 4 times 0. And if you multiply by 2, 14 minus 4 is 10 times 2 is 20. This is 6 times negative 3 is minus 18. This is positive 1 times negative 12 is minus 12. And they add up to negative 10. Again, we are going over that with details. For d sub x, everybody, we are going to replace the first column by this. So the first column, okay? That's what we do. And we're going to expand it. You get rid of these two, and you're left with that. You get rid of these two, and you're left with 3 minus 1, 0, 2. You get rid of this one, and you're left with that. I'm assuming everybody knows what we are talking about. So this is, again, the same as that one is 14 minus 4. This is 6 minus 0. This is minus 12 minus 0. And when you multiply them by 4 plus 3 and plus 9, you end up with negative 50. And for d sub y, we go back to this. Let me erase my board. And we are going to replace this one with this, okay? 4 minus 3, 9. And now we're going to expand it. Two times what is left, the determinant of what is left. By the way, this becomes, we are still using the first column, okay, everybody? We are expanding with respect to the first column. And what happens is that 2 takes a positive sign, then it alternates, okay? So you get rid of this column. For the first one, you get rid of this row and you get this one. For the second one, you get rid of this one and this one. Get 4092. And for the last one, you get rid of these two. So you get that. So this is minus 6, minus makes it plus 36. So this is 8, this is 0, this is minus 16. So this is 30 times 2, minus 3 times 8, 1 times negative 16. And we end up with 20. There's one more left, and that's d sub z. We got to find that. Which means in the next page, we are going to change this last column of d to this. By the way, this is the information from the previous page. Now this last column is changed. Okay. And we are going to expand it again with respect to the very first one. This column is 4 minus 3, 9. That's what we are saying here. In other words, this column, so this really should be here, this column has been changed to this one. Now we're going to expand it with respect to this. So that means 2 times this minus 3 times, get rid of this, have 3, 4 minus 1, 9. And finally, you have plus 1, get rid of this, you have those 4. So by now, you should be very comfortable with this, everybody, because we've done this, right? A number of times. And so 7 times 9 minus negative 1 times negative 3, 3 times 9, 27 minus 1 times 4, negative and negative becomes positive. 3 times negative 3 minus 4 times 7, those are the numbers. 63 minus 3 is 60 times 2, 27 and 4, 31 times negative 3, negative 1 and negative 28 times 1. That means negative 37. So add them up and you end up with negative 10, everybody. X is d sub x over d minus 50 over minus 10, which gives us 5. Y is d sub y over that gives us negative 2. Z is d sub z over d, so that means this number now, negative 10 over negative 10. That gives us 1. We are done. It's a good practice to check. So quickly, if you plug in the numbers, if you can write them as 5, negative 2, 1. You just plug in. The first one you plug in, it works. That checks. The second one you plug in, that checks. The third one you plug in, that checks. So you have to check, everybody. That's pretty straightforward. Let's quickly look at this one. We want to use Cramer's rule to solve the following. 1, 3, 2, 2, 5, 6, 1, 1, 7. That's the D matrix and therefore the determinant of that. We expanded with respect to one of the rows or columns. Okay. So this is 1 times those 4. Okay. minus 2. For we are using this. So the second one would be this 3127. The third one, you get rid of this one and you have this 4. You see that? You do the math. I'm going to go through this quickly. 5 times 7, 35 minus 6. 3 times 7, 21 minus 2. 3 times 6, 18 minus 10. Multiply this one by 1, this one by -2, this one by 1, and they add up to -1. Now to go to d sub x, the first column will change to this. One, 3, 1. So again, expanded with respect to the first one, 1 times what is left here. Okay. Minus 2 times 3117, and plus 1 times 3516. 35 minus 6, 21 minus 1, 18 minus 5. Work it out, you end up with 2. D sub y, the second column of the D has been changed to 131. Expanded with respect to 1, you have this part. Then minus 3 minus 1. Minus 1, because we are expanding it with respect to the first row class. First row, first row, first row. So the next one is minus 1. And then we have 3, 1, 2, 7. And then 1 is positive. We have 3, 3, 2, 1. So this is 21 minus 1, 21 minus 2, 3 minus 6. Multiply those numbers, add them up. You end up with -2. Now the last one is DZ. The last column will be changed, everybody. Again, expanded with respect to that. This is the one has been changed. So 1 times those 4 minus 2 times those 4. Okay, minus 2 times those 4. Minus 2 times those 4. Okay. And then plus 1 times this 4. So 5 minus 18, 3 minus 6, 18 minus 10. Apply the 1, -2, and 1, add them up. And now x is this one divided by this one. Y is this one divided by this one. And z is this one divided by this one. And the solution set becomes -2, 2, comma, -1. So that's pretty straightforward, everybody. So what happens when we have a dependent system? We can have a couple of more pages to go. If D is 0 and at least one of the determinant D sub x, D sub y, or D sub z is different from 0, then the system is inconsistent and has no solutions. If D is 0 and all of the determinant D sub x, D sub y, or D sub z are equal to 0, then the system is consistent and dependent so that there are infinitely many solutions. Properties of determinants. The value of the determinant changes sign if any two rows or two columns are interchanged. So look at this one. 3 times 2 minus 4 times 1 is 2. If we change it, it's 1 times 4 times minus 2 times 3. Because we change, see, the rows have been changed. The result is they are opposites. If all the entries in any row or column equals 0, the value of the determinant is 0. So if this is 0, 0 times 2, 0 times 1, the answer is 0. If any two rows or any two columns of a determinant have corresponding entries that are equal, the values of the determinant is 0. This one is identical to this one. If you expand it, 1 and you have those, minus 2 and you have those, plus 3 and you have those 4. This is 12 minus 15. This is 6 minus 12. This is 5 minus 8. If you multiply this one by 1, by minus 2, by plus 3 and add them up, you do get 0. As long as two rows or columns are identical, the result is 0. If any row or any column of a determinant is multiplied by a non-zero number k, the value of the determinant is also changed by a factor of k. For example, we've already known that this is 2. Let's multiply one of the rows by k. So we have 3k times 2, which is 6k, minus 4k times 1, which is 4k. That results in 2k. So 2 times k, because this row is multiplied by k, the result is multiplied by k. So if you multiply it by 10, it becomes 20. If the entries of any row or any column of a determinant are multiplied by a non-zero number k, and the result is added to the corresponding entries of another row or column, the value of the determinant remains unchanged. So this one, we know the answer is 2 from here. If we multiply row 2 by negative 2 and add it to row 1. So if I, in other words, 2 times 1 subtracted from 3, I get 1. 2 times 2 subtracted from 4, I get 0, right? 1 times 2 minus 1 times 0, I get the same 2. Nothing changes.